Okay, let's talk about some polygon angles. We've been dealing with triangles, and there are three angles for a long time. Remember, three angles inside any triangle always add up to 180. Okay, so that's our base understanding before we expand on this. All right, one thing about a parallelogram, which we should know a little bit about parallel lines, parallel means we have some same side interior angles. So these two angles right here would have to add up to 180 according to our same side interior rule. So that means this one would be 125. But since a parallelogram also has these being parallel, this 125 and that one are also same side interior going this way. So these two should be supplementary. So that one should be 55. And then I could turn around and make the same argument going this way, that these two should add to 180. And so, yeah, you do find in a parallelogram that opposite angles are congruent. They are. Okay, but one thing to notice right here, if you do the 125 plus 125 plus 55 plus 55, we're going to get 360. Okay, and so by the way we went about that, these two are 180, these two are 180, it makes sense that that's 360. So that's always going to happen in a parallelogram. And so as a matter of fact, that's something that all quadrilaterals are going to do. And I'm going to show you just a little example of that right here. If we just had a random quadrilateral, remember quadrilaterals means four sides. If I go to add these up, and let's say I get, let's say that I get 96, 97 degrees, it looks like. And I just start to measure these just by hand right here. That looks like 69 degrees. This angle looks pretty obtuse. That one looks like 130. And this one looks like 74. So if you go to add all those together, if I took some accurate measurements here, 69 plus 97 plus 130 plus 74. I must have looked at one of these wrong. I apologize. I think that's supposed to be one of these. I'm off by 10. So I apologize. I'm not sure which one it was that I looked at, that I was looking on the other side of the line. We'll just say it's this one, but just trust me here. These are going to add up to 360 degrees. Okay. I don't want to bore you with that, but I can demonstrate that again. I challenge you to use a protractor over there, be a little more accurate and a little more diligent than I was, and see if you can make this one over here work. Okay, they do add up to 360. Something we're going to discover here is why they add up to 360. So what's going to be important here is that you follow this large chart right here that we're going to fill out together. And I need you to fill it out with me. This is the discovery section of this. And when you see what happens when we go through here, you're going to learn the formula that I'm trying to teach you. Okay? So some of these categories may not make sense to begin with, but we'll just dive right in here. So a triangle, we know it has three sides, and there are 0 diagonals from one vertex because I can't draw a diagonal in there. I'll show you that in a minute. Okay, the number of triangles formed, well, I only see one. And we know the sum of these interior angles is 180. And we know that each interior angle is regular. So I need to talk about the word regular. Regular means equilateral and equiangular. All right, maybe you should write that up here. Regular means equilateral and equiangular. That means all the sides are the same and all the angles are the same. Not just in a triangle, but in any of these shapes down here at the bottom. All the sides are the same, all the angles are the same. Okay, so continuing on here. If we've already done this, because remember, if it's the perfect equilateral triangle, we know that all of these are 60, because I do 180 divided by 3. All right, so each, if it's the perfect triangle, there's 60. And then the exterior angle, this is the part we're going to focus on here for a little bit. Exteriors are formed by extending one of the sides. So if I extend that out there, I make an exterior angle here. I can extend this one out there, and you need to make these notes with me. And you extend those out there, and I make 3 exterior angles, and according to my linear pair rule, they are all 120. And that's what it says to do right here. Each exterior angle is 120. And the sum of the exterior angles, well, that would be 120 plus 120 plus 120. That is 360. All right, let's do the quadrilateral. So the quadrilateral, pencil for this, the quadrilateral, the idea here is that I can take and divide this quadrilateral into 2 triangles. And this one has 3 angles that we know that add to 180. And this one over here has 3 angles that we know add to 180. And then if I take that diagonal out of there, I just know that the 1 and 4, whatever those angle measurements are, they will combine together to make that whole angle. And 3 and 6 will do the same thing. And so the argument is that these 3 are 180 and those 3 are 180. So therefore, this adds up to 360, which was demonstrated over here on the previous page. That's what was happening here. It just wasn't regular quadrilateral. It's just a plain random quadrilateral. All right. But this is a regular quadrilateral. And I think my camera is doing something to make it stretching that right there. But I promise you, that's actually a regular square. Okay. So I know it's stretched in this other screen. I apologize. I don't know, what geometry is going on that stretch there, but it's stretching that in the screen a little bit. That's a square. So all the sides are the same, all the angles are the same, and then we can do this. So the reason here is I had 4 sides, and I could draw in 1 diagonal. That's the only diagonal I needed, and it created 2 triangles. And 2 triangles at 180 each add up to 360. And then if it is 360 and you divide by 4, 360 divided by 4 is exactly what we think it should be. It should be 90. So that right there would be a 90-degree angle. And then if we extend the exterior angles all the way around, we should get 90 degrees on each of these. Okay, so there is 90. And if I add all those 90s together on the exterior angles, that they would add up to 360. Okay, so we're about to get into the meat of this. I'm going to go ahead and stop the video just for size and file sharing, and then pick back up in a second video.